All right. No, missing one. No Naomi? Mama? All right. Good then. Good morning, everybody. Oh, I got people in this class now. I get to stand up, stretch. I bet that ding is Naomi. Yep, there she is. All right. Today is going to be a very talky day for me. Okay? We did a lot of hard work last week. So today, you do not get to relax. It is just as hard of work and just as important as it was last week. Today we are going to review the answers from last week's homework, and I'm also going to share some example responses from Friday's analysis of My Cousin Vinny. All right? This is critical, that you actually go through your answers and you check and you see, what did I get wrong? What did I get right? Pat yourself on the back. Ask questions. Why did I get this one wrong? What is the mistake I made, so that you can fix it for the future? This is the critical part of the learning bit, right? So, take out those logic exercises. We'll zoom on in. The first half of it was fairly straightforward. Which of the following are statements? A, what's your name? Nope, not a statement. That's a question. You did not have to explain why it wasn't a statement. I included that on my side for clarity. B, the rain in Spain falls mainly in the plain. That's at least a sentence. That's better than the last one. Is it a statement? It's a statement if it could be true or false. If you can say to that true or false, and that would make sense, then yes, it is a statement. The rain in Spain falls mainly in the plain. Yeah, that sounds true. Could also be false. Maybe it falls mainly in the ocean. Maybe it falls, I guess the ocean wouldn't be part of Spain. I don't know, right? Falls mainly on the mountains. Right? There is a way to make it false, so yes, it's a statement. C, Happy New Year. That's not enough going there. That's just an exclamation. It's not even a full sentence, right? There is no subject and verb. So no, not a statement at all. And D, 5 is an odd number. Yes, that's a statement. We're pretty sure it's true. And if you can say, yep, that is true, that's a fact, always the case, then it is a statement. Okay, question 3. Now it gets to be a little bit tricky. We're going to translate these sets of symbols into full-on English sentences. These are not complete arguments, but they will be some form of statement, recognizing the combination. So the R stands for roses are red, S stands for the sky is blue, turtles are green. We recall this little guy means and, right? Upside down means or. This tells us it's going to be an if-then. And that guy means not. So with all that together, you should end up with something pretty darn close to A, roses are red and the sky is blue. Not a lot of variation there. B, roses are red and the sky is blue or turtles are green. As long as you have these statements and those connectives in that order, I'd say you've pretty much got it. How exactly you wanted to separate it, because we don't have the equivalent of parentheses in English. I mean, you can use parentheses in English, but it means something different. It means this is an aside comment, not these two things should be grouped together first. So the way I've done the grouping is I've set the first phrase off with a comma. That's one option. You could also say roses are red and it is the case that the sky is blue or turtles are green. If you wanted to add another phrase to put those two things together, that would work as well. C, if the sky is blue, then both roses are red and turtles are green. This one's a little clearer on the structure. You have to have if then. This one has to be before the if, or after the if, before the comma. And then both of these are going to be there. I guess you don't really need to say both. You could just say, then roses are red and turtles are green. The word both is technically superfluous here, but it really helps clarify that, hey, I'm going to be talking about two things. Heads up. Don't just stop after I say roses are red. D, if turtles are not green and turtles are green, then roses are not red. I'd also say, if it is the case that turtles are not green and turtles are green, these are both talking about turtles. You could combine them. If turtles are green and not green, or if you want to keep the order, turtles are not green and green, you don't have to say turtles twice. That'd be okay. But all that has to come before, then roses are not red. I'll give you a minute to write here. Questions on these ones so far? No? Okay. On to the next set. Number 4, go in the other direction. Now we're going to take all these words and we're going to reduce them down into symbols. If it is raining, then the sun is not shining. So it'll be a Q. Implies not P. B, it is raining and the grass is green. Q, caret R. That's caret is the closest thing we have that you can press shift, 6 on the keyboard. It'd be a little bit above sometimes, but closest way I have to describe that. C, the grass is green if and only if it is raining and the sun is shining. This is a biconditional. We didn't talk much about this in class, but it was in your notes from this text. It's a double arrow. It goes both ways. R implies Q and Q implies R. Both directions work. So you have R, double arrow, Q and P. It's kind of funny, we skipped over, actually, one of my favorite abbreviations, since we went straight to full symbols. If you had to write this out and you get really tired of writing if and only if, you can also write if with an extra F. And mathematicians know that is also if and only if. Extra bit of trivia for you there. All right, D, either the sun is shining or it is raining. P, V, or Q. Be really careful here in the future, if you start assigning letters to things, try not to use the letter V for a statement because it's going to look an awful lot like the or symbol. All right, now number 7, our first set of trues and falses. Stop me at any point if you need an explanation on why one of these should be the way it is. A, P and not Q. That's true. Keep in mind we know that P is true, Q is false, R is true. Okay. I'm going to go down the left-hand side because that's easier for me. So C, not P implies R. That'll be true. E, not Q and P or R. That's true. R and not Q or R and not Q. Didn't I say Q? Not P and not Q. That would be true. H, P and Q implies Q or not R. Also true. B, not the case, P or Q. False. D, not P and R, biconditional with Q. Implies and is implied by Q. That's true. P or Q implies R, R implies Q. That's true. Okay. Questions there in person? I don't just mean, well, you think of asking something. Any of these that you got wrong, that after I've told you the right answer, it's not immediately obvious, oh yeah, that's the way it should be. Because the end of the quarter is coming. That's next week, Friday. You will have a test. It's quite likely there will be questions like this. You will have to determine the truth of some combination of statements represented by symbols. So if it's not at all 100% clear, ask now.
I have a question.
Yes.
So why is B wrong? Because shouldn't it be true?
Did you say D?
No, B.
B. This one. Okay, why is that one false? And it's the only one that is false. All right, let's take a look. Remind ourselves what is what. P is true, so we get a true statement. Q is false, so we get a false statement. And this means or. So together, that group is, it's true or false. Well, if I get to pick either one, like I want truth out of it, I'm seeking truth, and you're telling me I have to pick from one of these or the other. One of them will be true, or one of them is false, but I have equal choice. Be like, well, I'm going to pick P. I'm going to take this one. It's true. Whenever you have or, you get to choose the best one. So a true statement or a false statement together is true. The net result is you will always end up with a true statement. But then they stuck that negation in front of it, right? So that reverses the whole thing. Not true. Ah, shoot, that makes it false. All right, good question. Thank you. Any others? All right, then moving on. 11, as I mentioned, I would ask that if you're typing this out, you might have more writing to do. I was lazy, and I just highlighted these, which you are perfectly allowed to do if you are also making use of the document and could edit on top of it. That's fine. So the hypothesis and the conclusion of the whole argument. All football players are introverts. That's one hypothesis. Tony is a football player. Also a hypothesis. The conclusion then is Tony is an introvert. There is only ever one conclusion at a time, and everything else is hypothesis for the bare minimum basic unit of argument. Remember, you can make one small argument, combine it with another small argument, and write out a much larger argument, much as like the My Cousin Vinny examples, right? The whole dialogue was several small arguments put together. These are each one small argument, so there should only be one conclusion in each spot. Bob is taller than Jim, hypothesis. Jim is taller than Sue, hypothesis. So Bob is taller than Sue. That's the conclusion. Questions there? Okay. All right, determine the validity of the following arguments. All professors are handsome. Some professors are tall. Therefore, some handsome people are tall. Right? That is totally valid. All of the professors are handsome. So some handsome people are going to be professors. And if they are professors, some of them are tall. So yes, there could be some handsome people that are tall. Valid. So that is actually a form of modus ponens there. B, if I can't go to the movie, then I'll go to the park. I can go to the movie. Therefore, I will not go to the park. That is invalid. You have negated the hypothesis here, the antecedent. You reversed that. That doesn't tell you anything. Yeah, I can go to the movie, but I could still change my mind and go to the park anyways. Right? So that's not a valid conclusion. C, if you score at least 90%, then you'll earn an A. If you earn an A, then your parents will be proud. You have proud parents. Therefore, you must have scored at least 90%. It sounds pretty good, doesn't it? Like, ooh, that's so close. It's like, okay, I've got this final thing. I must have gone through this path. But no, it is invalid. That is not the only possible way to have proud parents. It didn't say that. We could have said, only if you scored at least 90%, you get an A, right? But it didn't say that. You could have proud parents because you did really good at the sports game last week, and they're proud of you for that. You could have proud parents because you were very honest with them about your grades, right? Even though it's not an A, you didn't try to hide your report card. And they're like, well, thank you for being honest. We're proud of you for that. Any number of other things could have led to this. Invalid. Number D, some ARPs are bombs. All bombs are certs. Therefore, some ARPs are certs. That is totally valid. I have no idea what ARPs and certs are. Doesn't matter. Okay? But some of the ARPs go into that category. Everything in that category is also in this category. So clearly, those same sub-ARPs are in that final category. That's a law of syllogism. Whenever you see these ones that are phrased with the some and all, I encourage you to draw the Venn diagram for these. Because then you'll okay, some arps are bombs. So we got a circle of arps inside the circle of bombs, but not all of the arps are inside the circle of bombs, but all of the bombs got to be inside the certs, right? So you could do something like that. And then, oh yeah, there's some of those that are inside the other one. Yeah, that works out. All right, E, all equilateral triangles are equiangular. All equiangular triangles are isosceles. Therefore, all isosceles triangles are equilateral. No. Invalid again. This is the same as the last one. Just because you give me the final thing doesn't mean I get back the positive of the first one. Right? If you gave me the opposite, right? Modus tollens would tell us, oh, we could negate that and say if it's not isosceles, then it's not equilateral. That would be true. But you didn't do that here. The inverse is not automatically true. This is invalid. F, if you work hard, then you will succeed. You do not work hard. Therefore, you will not succeed. That is invalid. A lot of people try to tell you this, all right? And if they do, you can tell them, nuh-uh, that is invalid. It is still totally possible. I could succeed despite not working hard. You could get very, very lucky. You could find out about some rich uncle you didn't know you had who dies and leaves you $1 million. Like, hey, I'm set now, right? You didn't have to work hard for that, and you're fine, right? It didn't say the only way to succeed is working hard, right? So it's invalid. However, I will tell you, in my experience, you probably do still want to work hard. That's going to be necessary most of the time. Unless you already know of this rich uncle. Right? All right, G, some girls are teachers. All teachers are college graduates. Therefore, all girls are college graduates. No, oh, it was so close. Right? Okay, the girls are teachers, and the teachers are college graduates, so you could have said some of those girls, the ones that were teachers, are definitely college graduates. But it tried to say all the girls are college graduates. Shoot, they went too far. You don't know that. That is invalid. H, if it doesn't rain, then the street won't be wet. Sounds reasonable. The street is wet. Therefore, it rained. That's valid. That's modus tollens right there. All right. Any questions on these guys? All right. On to the next one. 15. Necessary and sufficient. This is one of the trickier ones on here, for sure, especially given the format, right? Just determine whether P is necessary for Q, or P is sufficient for Q, or P is necessary and sufficient for Q. So it's only going to be one of those options. A says, P, Bob has some water. Q, Bob has some ice. Okay, so do I need water in order to make ice? Yes. Correct? Is just having water enough to make ice? If I give you a glass of water right now, can you just turn it into ice? From no other tools or resources? Absolutely not. You need to go to the freezer, right? And you'd put the water in the freezer. So just having water is not sufficient for making ice. You need water plus cold, right? On a really basic, simple level. Something else. So that's why it just gets one I. It is necessary, but it is not sufficient. All right, B. P says it is snowing. Q says it is cold. All right. If it is snowing, is that necessary for it to be cold? Do you need snow in order to have cold? Go outside this morning. Was there snow? But was it cold? Yeah. So snow is not necessary for it to be cold, right? We can agree on that. We can have cold days without snow. But is knowing that it's snowing sufficient to conclude that it's cold? Have you ever had it snowing outside and it was still warm? You might have a warm day and there's snow left over on the ground, but it's not currently snowing. It's definitely cold. If you look out the window and you see snow coming down, you know it's cold outside, right? So snowing is sufficient for it to be cold. That's enough information. I don't need to know anymore. I can make the conclusion. Definitely cold. 2 I's. All right, similarly, P says it is December. Q says 31 days from today, it is January. All right, to go 31 days from today into January, does it need to be December? Is being December necessary to move 31 days and end up in January? Let's try what's like the extreme case. If it's December has 31 days on it, right? So if it's December 1st, 31 days later, it will be January 1st. That works. November 30th, one day before, 31 days after, you'll be on December 31st. You won't hit January, right? So I think this one is, I think it's necessary. I need to add an extra I here because it's also going to be sufficient. Right? As long as you know you're in December, 31 days from now, I'll definitely be in January. Think about what's the extreme case. If you don't end up in January, you'd be in February. December 31st, 31 days later, you're still in January 31st, right? They both have that 31 days. That helps. So really, we should have 3 I's here. It is necessary and sufficient. Apologize for that. I missed one. Right. Questions so far? Make sure I'm not missing anything online. Okay. Keep going. 17. Which law is being used in these arguments? If Joe is a professor, then he is learned. Nobody really says that anymore, but it's a phrase. You can say that. If you are learned, then you went to college. Sounds reasonable. Joe is a professor, so he went to college. That's the law of syllogism. I just wrote it as syllogism. I didn't write law of each time. Yes. B. If you have children, then you are an adult. Bob is not an adult, so he has no children. That would be, I would say, law of contraposition. You could also view it as modus tollens. I went ahead and said contraposition because they wrote it out as one whole sentence here. That is the contrapositive there. I would totally accept modus tollens as an alternative here. In fact, let me go ahead and just stick that here in parentheses. Could also call it modus tollens, being Bob is not an adult would be your additional statement, and then the conclusion would be he has no children. Treat those separately and accept that. All right, C, if I am broke, I will ride the bus. When I ride the bus, I am always late. I'm broke, so I'm going to be late. That is mainly a syllogism there, combining those two conditionals. Although I think I would like to add I'm broke, so again, treating like this whole statement as your conclusion. I'm broke, so I'm going to be late would be the syllogism. If you say I'm broke as a separate statement, I'm going to be late would be the final conclusion. You could say this is actually a two-step and be and modus ponens slash detachment. That would work as well. If you included that, you are not wrong. Depends on, are we trying to look at this as a single-step argument, or is this a double-step argument all here? All right, questions there? Yep. 19, here we go, another true or false or unknown. Oh, this one's extra sneaky because A and B are true. P and Q are both false, but X and Y have unknown truth values. So this gets a little tougher here. You can only determine the whole thing here to be true or false, even if it has an unknown, if there's only one possibility. So this is where the truth tables really come in handy, because you have to check, okay, this unknown, it could be true, and the net result is still true. Or this unknown could be false. You look at the table and net result, oh, the whole thing is still true. So if it's true either way, then the whole thing could be true, even though one of them was unknown truth value. So here we go. If P, then A or B, that's true. If B, then P or A, also true. If X, then P, I don't know, because I don't know the value of X. If X is false, false hypothesis can lead to anything. That would still end up true. But if X was true, and it led to a falsehood, that would be a false implication. You broke your promise. You said it was going to be true, and then you ruined it. False. I don't know yet, so the whole thing is unknown. D, A or P, true. I always get to pick the best one. E, if B, then Q, false. Exactly what I said. You start true and you end false, you're screwed. You're false. You lied to me. F, if B, then X. I don't know. Right? Because again, B started out as true, but I don't know if the promise was kept or not. So that's unknown. G, A and B or X. That's true. No matter what X is. I always get to choose the best one, so it stays true. H, Y or X leads to A. It's true. I, if Y and B, then P. Unknown. Because this is an and conjunction. Y is unknown. If it's true and true, the whole thing is true. But if it's false and true, then this starts out as false. And now I can't determine the conditional because I don't know if I started as true or started as false. J, A or X implies B and Q. That's false. K, if X, then A. True. I know what you're thinking. Hey, wait a minute. How come C was unknown? X implies P is unknown. But X implies A? That's true? Because A is guaranteed true. So either X started as true, and I said, if something true leads to something true. Perfect. That sounds great. All true. What if X was false? If something false, then true. If pigs can fly, then the grass is green. Well, pigs can't fly, so it doesn't really matter, right? If you start with a falsehood at the beginning, what ends doesn't matter. It's technically a true statement, yeah. Because he didn't break the promise. So there's no way to break the promise here because I ended with true. The whole thing is true either way. L, X, or P is unknown. M, if not X, then X. That's unknown for the same reason that K is. Not sure how I started, and I'm not sure how I ended. This is like, M is, am I looking at C or K? I don't know, so therefore I don't know. I really don't know that one. N, X or not X. That's going to be true. This is really convenient. If you can narrow down, like, hey, it's going to work either way. Whether it is or it isn't, I don't care if X was true. I don't care if X was false, because I can always pick which either one. Whatever it is, I have the opposite. And O, it is not the case that Y and not Y. That's true. For the same reason here. Whatever I end up with, I can always pick. Well, similarly, whichever I end up with, they're not going to match. And so the and instantly becomes false. But it's not the case of that whole thing, so the whole thing flips to true. Okay, I tried to explain most of these as I went. Any questions remaining? Yep. All right. Almost done. 24 was the Euler diagram. This is just looking inside here and say, hey, can I put a dot here? And would it still be in that circle? So all women are mathematicians. Is the whole circle of women inside the whole circle of mathematicians? No. There's one out here, so that is false. It's not all. Is Euclid a woman? Euclid's over here. Is that dot in the woman's circle? No, it's false. All mathematicians are men. False. All professors are humans. True. Some professors are mathematicians. True. Some. I just need any crossover. Euclid was a mathematician and human. He's here. He's in the math circle. Everything's in the human circle. True. Oh, sorry. Questions there? All right, and then wasn't there one more? That was it? Whoops. There we go. Okay. Last call questions from this document. It sounds to me we have 5 more minutes. So with those 5 minutes, I want to share with you some conclusions from my cousin Vinny. Lots of good stuff on there from everybody. Also saw a lot of confused statements, either ones that didn't quite fit, you didn't quite make it clear why the bit that you picked fit that one. Some people only, like they only had one of the sentences there. It's like, this is only one sentence. You can't form the whole argument from just this one thing. Or other people made some of the mistakes, like we just saw some of those invalid arguments. They were set up like, oh, you messed it up. That wasn't modus tollens the way you phrased it. So here are some good examples. All right, so compared to what you got from that, here's a few. If it took him 5 minutes to make grits, then it must have been instant. Right? Oh, 5 minutes. Were those instant grits? Because that's how I would know. That's the only way you could have done it in 5 minutes. Must have been instant. But he said the grits were not instant. Therefore, he did not take 5 minutes. Modus tollens. I thought that was great because we spent most of the time about that 20 minutes after, but this one was right at the very beginning. We already narrowed it down. Not instant grits. Couldn't have been 5 minutes. All right, law of syllogism. If the boys went into the store earlier, then Tipton was making breakfast. If Tipton was making breakfast, then he was at home when the gunshot happened. So two statements and then combined into one. If the boys went into the store earlier, then Tipton was at home when the gunshot happened. All right, this is another good one, partly because I don't remember who wrote this one. I just sort of grabbed things where I found them. Didn't want to call anybody out. Right? But this wasn't based on the actual dialogue, or not word for word. Right? So they've kind of read into it and found another spot. Well done. You see when the left tire mark goes up on the curb and the right tire mark stays flat and even. Well, the 64 Skylark had a solid rear axle. Okay, so what's great about a solid rear axle? Well, when the left tire will go up on the curb, the right tire would tilt out and ride along its edge. But that didn't happen here. Right? So we get a law of contrapositive, not quite as stated, because she didn't finish that didn't happen, therefore, it didn't go up on the, right, that didn't happen, so you couldn't have had the solid rear axle. Right? That's law of contrapositive or set up for modus tollens, right? Good. And because both cars were made by GM, were both cars available in metallic mint green paint? She says they were. Again, slightly unsaid, you got to add to it, but that would be modus ponens, correctly identified. He sets up the conditional. If made by GM, then metallic mint green paint. She agrees, they were made by GM. Therefore, left unsaid was, both come in mint green paint. Here's another one. If you make grits for breakfast, then they would take 20 minutes to make. Therefore, it didn't take you 5 minutes to make them. Law of syllogism, slightly implied here. Right? What we're skipping over is the if it takes 20 minutes, then it doesn't take you 5. We didn't write that one out. It almost seems like well, yeah, obviously, if it takes 20 minutes, that's not 5. Okay? But that statement is hidden in there, and that's what allows us to say this is actually a syllogism. We've combined those two ideas. Here's another one. If it takes 20 minutes to make grits for everyone, then Tipton did not make breakfast in 5 minutes. If Tipton did not make breakfast in 5 minutes, then Tipton, not Tripton, is lying about the chance of there being 2 customers coming at the same time. Conclusion, if it takes 20 minutes to make grits for everyone, then Tipton is lying about the chance of there being 2 customers coming in at the same time. Right. Here's a nice modus ponens. If Vinny wants Lisa to explain, then he will say, I would love to hear this. Vinny says, I would love to hear this. Therefore, Vinny wants Lisa to explain. That was another example of trying to pulling out and creating a modus ponens scenario, even though it wasn't phrased as such within the dialogue. All right, so this posted there, I'll let you read the other two at your leisure if you'd like. Otherwise, you've got 2 lessons on study.com this week, and we did this. It's going to be a fairly, no, Tuesday is going to be a heavy work day. Wednesday will be a little lighter, all right? And then Friday, I will be posting a review packet for your long weekend to review before test in 2 weeks, okay? So that's what's coming up. With that, you are dismissed. So long, farewell, enjoy the rest of your day.